So let's just get into it. So there's a bad math example here, but what I'm going to do is I'm going to give the presentation first so that we can enjoy the bad math even more, because the bad math I'll give at the end when I'll show examples of when charts can go horribly wrong. Okay, so this presentation is going to be a fairly quick one today. So we're going to go through what is a chart, why do we use them, the different types of charts available, what makes good and bad charts, and then I'm going to show you quite quickly what it looks like at Statistics Canada when people are trying to create charts. So let's just dive right into it. Okay, so a chart, as we all know, because all of our offices use them, it's a way to provide visual presentation of the data. So charts have this ability to show large amounts of information in a way that's very easy for people to process and to compare. And charts are used to show the relationship among sets of values. So I can't imagine a scenario where we would want to have a chart that would just have one number on it. So for example, like unemployment this month, let's say it's 11%, and the chart just literally had an 11% on it. It's used to compare things over time. It's used to compare relative sizes. And so that's sort of the forte of what a chart does. So again, let's just keep moving forward. So it's very important to choose the right type of chart. So the goal of a chart is to help to tell the story of the data. Ideally, this is what we're trying to do. I hope that none of you, I hope no one's using charts to try to confuse people. We're going to see examples of that when we get into the bad math later. But wrong charts can confuse the user, and it can also mislead the user. Tracy's recording this session. I didn't put a slide in that I wanted to because it's sort of embarrassing for Statistics Canada. But even though it's being recorded, I'm going to say it. A few months ago, Statistics Canada published a chart that was, in my opinion, and probably the opinion of everyone who looked at it, the 100% wrong type of chart to use. And it was sort of instantly confusing for everyone who looked at it. And we sort of have this understanding that when we see certain types of charts, we expect it to represent a certain type of story. So, for example, line charts tend to be longitudinal. They're telling a story over time. A pie chart, this is telling you how much is divvied up amongst a population, so 100%. So if you use the wrong one, it's going to be very confusing. So it's either going to potentially confuse the user or mislead the user, which is even sort of more concerning. So what we need to think about, how is this data going to be used? So who is going to be using it? Who is the target audience? And what's the best way to map out this information? So this is something we should always have in our head when we're producing these reports is who's going to try to access this data? How can we make it clear for that population? So if you're doing a very detailed statistical, like an economic forecast type thing, much different than if you're doing something that you hope the general population sort of picks up on. One of the quality metrics that we measure at Statistics Canada is the number of clicks on certain articles and certain links. So this is something Statistics Canada is financed by our Treasury Board, and they want to know every year, how many clicks have you had on the website? How much traction are you getting with certain things that we're publishing? And so Statistics Canada works very hard to make these charts that people sort of enjoy looking at, and more importantly, maybe share the data. So it could be, we're going to see this when we get up to the infographics, it could be something that I was mildly interested in or maybe not interested in at all. And then all of a sudden this graphic pops up and I'm like, oh, this is visually appealing. It draws me in. And then I say, okay, I'm going to look at this. And then I might end up sharing it, whether it be on Facebook or Twitter or some other social media. So this is where we are in this day and age. It's all about making sure that users are using our data and sort of spreading it. We can produce, this is going more to quality than to charts, but you can produce the most amazing statistics possible. And if no one is accessing them, you've missed that sort of metric in quality, which is the fact that people are actually accessing the data that you're creating. So the three that I'm going to talk about today are pie charts, so relations of parts to the whole and comparing categories to each other. Column and bar graphs. In fact, look, I forgot to take the word graph out here. So this should say graph instead of chart. So compare and emphasize the magnitude, so it can show time series over a few periods. And then line graphs are meant to show a series of over many periods. So we'll tend to watch a line as it goes through time. I've found this very interesting. This is something I only learned very recently, that in French, they call these things a camembert, which is a type of cheese. So the French are a little bit more focused on cheese. When they look at this, they look at it like a brick of brie, which is sort of like camembert. Whereas in English, we call these things pie charts. So here's an example from Statistics Canada from 2017. I just picked this one up to show this is a very good way to do this. So we put all of the labels on our chart so that we can see it right away. So for example, the yellow one we see, it says mixed income 8%. We see the source, which is down below, which is the Statistics Canada Industry Accounts Division. And I've kept the reference over on the right there in that box. It's for measuring the economy region by region. So this is sort of a very visual appealing. The colors contrast very well. It's going to be difficult, unfortunately, if someone is blue-green colorblind. They're going to have a lot of trouble with this. But at least the lines are fairly well defined, and you can see each of the percentages. Putting the percentages directly on the pie chart really helps with usability of the data, because I don't have to sort of guess. I look at those two biggest wedges. It looks like it represents a lot. I don't have to just guess. I can look and see that 39 and 43 make 82. And so that represents 4/5 of my pie chart here. So metropolitan gross domestic product, 4/5 of that is wages and salaries and operating surplus. So that's an example of a pie chart. They're primarily used to illustrate the different parts that make up a whole. So we want to design this thing to visualize the whole and see how it's subdivided. This is best if there's, let's say, a maximum of 5 to 7 categories. It can get tricky if there's more than that. If there's more than that, what I recommend people do is you try to roll up and roll down, in the sense of, if you have more than 7 categories, perhaps you can put a couple together in a main graph and say a more general context. For example, let's see if we can go back and see one here. We might try to glue like those 3 smaller ones. We could say other, and then we could take those other 3 and make another pie graph beside it. Says amongst other gross domestic products, these are how these 3 break out. So there's different ways to do this. They need to be mutually exclusive, distinct categories. So this doesn't work with mark all that apply. I have seen people try this, and imagine mark all that apply. You have, let's say you have 10 respondents and they all pick 3 things. It ends up looking like you have 30 respondents. So it doesn't work at all. So you can't use pie charts with mark all that apply. So here's another good example of pie chart. So again, I put each of the labels on each of the wedges, and I put the percentage associated with it. So this is sort of just I think I made this example up just to show what it looks like when we do something like a household spending survey. Avoiding 3D pie charts. So I think most of you are probably too young to remember when this happened, but there was sort of huge breakthroughs in publishing abilities in the late 80s and early 90s, where you would get Microsoft Excel came out, and the ability to create these graphs became, at the touch of your fingertips, anyone could do it. And because this option of 3D graphs was offered, a lot of people jumped on it and said, "Oh wow, this is new and cutting edge," but it's really discouraged. And so, for example, in this is a very good example. If we look at transportation, which is the purple wedge on the right, and food, which is just above it, the area taken up by the purple wedge is much bigger, because we see that face as well, is much bigger than what we see for food. So just from looking at it quickly with my eyes, I would say the purple wedge is much bigger than the yellow wedge, because I can't see the face of the yellow wedge. And so it gives us an implication that the things closer to us are more important and bigger, because they have this extra sort of third dimension. That being said, sometimes when we get into the infographics, they do this, but they're very careful about it. If you go on the internet, there are hundreds of examples of 3D graphs trying to show a certain set of numbers and accidentally messing it up, because instead of looking at the surface area, the 2-dimension, they end up looking at the volume. So just a word of caution to everyone out there. All right, let's take a look at the bar charts now. So I think this is the one that 100% of agencies said they did. So that totally makes sense. This is a very easy way to show data. So this one here, it's the percent of population by broad age groups from Canada from 1996 to 2011. And you'll see that we have 0 to 14. So in the mid 90s, 0 to 14-year-olds represented about 20% of the population. And this has been decreasing over time in Canada. And we see that if we look at the third group, which is the 65 and older, by census for the past 4 censuses, this has been going up. So our population is aging. This is true of a lot of places, and this can be seen in this chart. But the 15 to 64-year-olds still make up nearly 70% of our population. So with our bar charts, these are used for comparing differences between a small number of categories or a small number of time periods. So here we have just 4 time periods. It works quite well. There's only a total of 12 bars here. So this is sort of under control. It works very well. It's very visually appealing, I think. We can also stack them, which I'm going to show, I think, on the next graph, to show multiple choices for one category. So, for example, questions about levels of satisfaction, this is very, very commonly used with a stacked bar chart. And we can either separate this data into different bars or columns. Oh, it's coming up in a bit. So the good practices with bar charts. So scale is incredibly important. And again, this is somewhere where you can mislead the reader. And I have a really good example of this when we get to the bad math, and I'll show it to you. Avoid using too many bars. So it becomes very tricky. We want to put a lot of different comparables onto charts quite frequently, but it's just, we'll see some examples. It's really something you should avoid. You need to keep the numbers sort of at a minimum. Sometimes it's better to use a table. So for example, tables are good ways to represent a lot of numbers all at once. Again, never use 3D charts. There should be an asterisk here because really I would say never, but there are examples where people do this and it works okay. Cite your sources. We saw this. I've cited the sources on one of these tables, and using proper labeling and titles. So it's always important for people to know. At Statistics Canada, the rule basically is you should be able to pick up a chart out of a newspaper, off a table, wherever you get it, and you should be able to know what its source is, what all of the axes mean. You shouldn't have to say, oh, I'm going to go, like, there shouldn't be a little asterisk that says, please go look here to see this information. It has to be 100% contained within the graph, the chart itself for you to look at. Okay, so here is an example of a stacked bar chart. So this is region of birth of Black immigrants by period of immigration Canada in 2016. So this was a census question on our long form census. As Tracy mentioned earlier, our short form census only has about a dozen questions: place of birth, age, and languages spoken. Our long form census has many more questions. So for example, we can do analysis like this. And we see that before 1981, the vast majority of Black immigration to Canada was from the Caribbean and Bermuda. Why Bermuda is singled out there, I'm not sure. I'm not sure. But we see as time passes, it switches much more over to African immigration. And this is an example where we have a bit of a problem. So we see at the top, the Caribbean and Bermuda is blue. We see rest of America is sort of that grayish color. Then we see Europe, which is that brown stripe. Then below it is Africa. So Africa, there's been this much more changing dynamic of immigrants coming from Africa. But then Asia and Oceania, you can see it in 1991 to two, like you can see in the last 3 columns, there's a little blip at the bottom. And so this one, despite the fact that it's a StatsCan publication, it's a little bit problematic to me because for 3 of the bars, we don't know what the number is. So I couldn't tell you just from looking at this graph from 2011 to 2016, what the rest of the Americas, Europe, and Asia and Oceania represents. I know that just doing the math here, it's 92.4, so it's 7.6. Those 3 regions represent 7.6%, but I can't break it down just by looking at this. So they probably should have had little tick lines coming out and saying, these numbers in here are this. Okay, now we've done bars, now we're gonna go to lines. So for these line charts, this is population growth from 1997-98 to 2017-2018. And we see at the bottom, the source is the demography division, and they measure it year ending June 30th. And so each of these years, it's just what's our population growth rate? It looks like it's hovering at about, I don't know, 0.9%. So this is a very good example of how to use a line chart. Which this is something I've said with every single one of our categories so far. We want to avoid using too many categories. So I definitely have an example of this coming up. Scale is also critically important here. So if we look back at this, it goes from 0 at the bottom to 1.6% at the top. This is a good scale. We can see the line movement. If they had made this 0 to 100, this would look like exactly a straight line at just under 1%. It would crush the entire thing. We also don't want to space it out too much. We wouldn't want to do, I don't think, like 0.7 to 1.5, because then it would make the lines look too dramatic. So you have to sort of pick a scale that works to deliver not only the message you're trying to deliver, but to give an accurate representation of what the data is giving you. Again, cite your sources and use proper labeling and titles. I include this on every one of them because it's just important to do. So this is not an official StatsCan publication. This is just to show how horrible this can look. So we have 10 provinces in Canada. So all of these, and you'll see the fourth one there under Quebec is CAN, which is Canada. So that's the national total. You can't put 11 lines on one graph and expect anyone to do anything with it. It's just horrible. So unfortunately, if what we would have to do is we'd have to do something like, we have regions for these provinces. So we could say Canada, and then we could do Western provinces, Eastern provinces, and then maybe Ontario and Quebec as their own because they're so big. So there's ways to get around this, but you would never want to put them all on the same graph like this, on the same chart. All right, we're almost through the part on basic charts. This I left in here just to show you, this is how Statistics Canada sort of has these placemats. So you can see, I want to create a chart for publication. We can get this from our dissemination people or our media people, and they'll say, okay, this is what you have to do. This is how it has to look. So if we start, I'm not going to go through the whole thing, but I want to look at a couple here. So if you look right inside the graph itself and the chart itself, we see background has to be white. For bar and pie charts, you have to use a 0.75 black border around each color. So that helps people that are colorblind. And then there's all sorts of different rules about how we're going to create these things. So it used to just be sort of willy-nilly. People could create whatever they wanted. And StatsCan eventually said, no, we have to sort of standardize this. It has to look a certain way. I got a question from someone. So what is considered too many bars bar graphs? So I'm just going to go back. How many, actually, let's go back to this one. So how many is too many? I don't think there's a hard and fast answer to this one. I think you sort of have to take a look at it yourself and just say, if we had added, say, more age groups, so there's more groups of 4, I think that would have been fine. But if you start to put, like if we try to put, for example, like 10 censuses in here for each one, we'd have 10 groups in each of these 3 categories. That's certainly getting getting excessive at that point. So you have to sort of decide for yourself and just be honest with yourself when you're looking at it and saying, can the reader immediately see what I'm trying to say? And is it just a visual distraction? So I guarantee there's not a set rule. Thank you for that question. All right, so right. So this is the way, if you want to create charts of Statistics Canada, if you want to create anything in Statistics Canada, there's always sort of these style guides that you have to look at. All right, so in conclusion for the charts, so your information has to be clear to the reader. That's the whole point you're making this thing. A good chart will tell the story all by itself. They're going to complement the message you're trying to project. So as soon as someone picks this up, let's say there's a lot of text and other numbers with it, this is the thing that's going to catch their eye first. They're going to read it, they're going to look at it. It's okay. Now I want to read the article or their press release or whatever it is that you're using to find out exactly what the story behind all this context is. They should be used in a clear way that don't mislead people. You got to choose the appropriate graph type, and honestly, keep it simple is maybe it's the reason it's the last point here. It's probably the number one thing that we should do is we want to keep it simple so that it's easy for people to understand. Okay, I'm going to switch gears now. Now I'm going to start talking about infographics. About 3/4 of the organizations produce infographics, and this is sort of I don't know if cutting edge might be giving it too much credit, but it's certainly something that statistical agencies and others are adopting more and more. So again, I mentioned this when we were on the chart side, that part of the way the Statistics Canada's work is measured by the amount of engagement with the general public. So the general public may be using it as researchers, so they may work at a university or in a bank or something, and they may be accessing our data for that reason. Those people we never really have to worry about. When we produce statistics on the economy, the bankers are never going to say, I'm going to take a pass this month on reading your official statistics. On the other hand, the general public, if we can't the more engaged we are with the general public, the more likely they are to answer our surveys, the better our data becomes. It's this win-win. So the more they're using it, the more they're engaging with the data, the more likely they are to give us data, and the more likely we are to give them stuff that they like to look at. So, or inform themselves with. So this is where this idea of infographics came up. And I'm not sure exactly where Statistics Canada got it from, but it's relatively new. So why do we want visual products? I could have put this in front of the charts one, but I wanted to keep it separate. So they work. So Statistics Canada has started using a lot of these things. This is the statistics I said that were coming up. So if we process visually 60,000 times faster than text. So we sort of see a graph and immediately, we may not know exactly what the graph is saying, but we can see trend right away. Whereas if you say, look at the trend in this data table, it's going to take you a bit more work to notice that this is happening. So visuals are 30 times more likely to be read. So if you put a graph on if you put a chart or an infographic onto a page with text, people, it's a guarantee that they're going to start there. People remember 80% of what they see and do and retain only 20% of what they read. So they're much more likely to retain the information as well. And infographics are shared, and this is again going to our quality mention of accessibility. Infographics are shared 3 times more than other posts on social media. So if it's got the sort of appealing look to it, people are more likely to share it on social media. So there's many different ways we do this. So we have these infographics, social media posts, and info bites, we call them as well. And we also have videos and GIFs, and I'm going to show us one of those in a minute. So this is kind of an interesting one. Hopefully it's working for everyone. This was a short little clip that they made with respect to electric vehicles in Canada. And so the data comes from a much bigger report, but then there's this sort of fun little infographic or fun little GIF that people can look at. And it's a very good way to get people engaged. If people see this, they're sort of likely to stop and look at it, which does his engagement. And they might share it and say, look what Statistics Canada is doing. They're producing these short little sort of fun videos of how data works. And so that's good for us. So I imagine these things are, well, I guess if you're skilled at this, it's probably not that difficult, but they can be challenging to create if you don't know how to do it. So this is just one thing this is one of the ways that Statistics Canada does this. And we have more than just this one. So what is this infographic? What are we doing? So it's a portmanteau. So it's a smushed together of 2 words, which is information and graphics. So it's just a graph which contains information. So it's a visual representation of the data. So obviously we always want to have the theme of the data represented in the theme of the graphics. So this first example here is Canada in the outdoors, and we see there's someone's camping in the forest, and then they have all sorts of statistics around it. So again, it's meant to visually catch people and bring them into the data. If there was a table, if there was an article about Canadians in the outdoors, I might read it. If there was a chart about Canada in the outdoors, I would see it. I would just happen to sort of absorb some of it. But with something like this, it's much more likely that I'll spend some time and look around. The pictures are visually appealing, and also then I retain the data as well. It's our bread and butter. Here's one where they put together and they were talking about the cost of importing certain consumer goods, I think it was. This one's a little bit wordy. We're going to see on the next slide that you shouldn't put too many words on one of these things. These ones, so when I said that in the previous half of the presentation, I said in charts, they have to stand alone. In these ones, the graphic doesn't need to stand alone. This should have a reference to a link somewhere in it, I hope. Yeah, nope. Somewhere it should say for more information, go and see this. So that's missing from this one. So this is something we want to do. So we draw them in with this picture of the hamburger, and then they look at, okay, look. Now, of course, hamburger buns, mayonnaise, mustard, pickles, lean ground beef, and ketchup are not the greatest concern of tariffs and consumer prices. It's much more going to be on natural resources. But this is the one that draws the people in to think about it. This is the one that draws them in to know that this data is available. So not super, these ones are not super important standalone, but they're indicative of the fact that this data now exists in StatsCan somewhere, and they can go and have a look at it. At the bottom, they talk about, do you notice anything wrong here? And this usually leads to a class discussion. I'll tell you what it is. They put cucumbers on their hamburger instead of pickles, and they also use two tops of a bun. So there's no bottom to this hamburger. So we want this thing to tell a story. We can't be jumping all over the place. So the infographic itself has to have one coherent story in it. And the data and the text it's got to be visual. They have to work together. You'll see that at the bottom, it talks about keep it to 4 to 5 data points between 2 and 250 words. So the one on the right here, which is a static version of that GIF I showed you, this one works well. If we go back, there's a little bit too much, in my opinion. There's a little bit too many words in the title, in the sort of introduction, and there's a little bit too much down in the notes. At least in the notes, they pulled it out using that yellow color to highlight some stuff. And this one's better in my opinion. There's a lot less text here. Titles are important. So Seniors Online, it's going to pull you in. They're going to talk about seniors using technologies. So titles, we want it to be 5 to 6 words. It's got to be factual and suitable for your subject matter. Obviously, can't use something that's incorrect. So, and the title cannot be identical to the name of your survey. I think the reason for that is because most of our surveys have the word survey in it, and it would look sort of weird publishing results with the word survey. You want when you're doing infographics, you want it to be interested to the general public. You want people to be consuming this. Again, this isn't like, you wouldn't do this with labor force statistics. You wouldn't do this with raw tonnage of imported goods for certain raw materials, because the bank people, the people that work in those sort of fields, they're already looking for this data. And to be honest, if they're working in this data, they probably don't want an infographic making it hard for them to find their numbers. They want something very specific. And if you month after month produce it the same way, they know exactly where to go. They know where to go to look for their unemployment statistics. They know where to go for their import-export statistics. They don't want this stuff. This stuff is much more to engage the general public with their data. We want to use plain language. So this is true of all StatsCan stuff, but maybe even more so these infographics, where we're trying to sort of gain new users of our data or new accessors of our data. And so we want to avoid jargon. The general rule of Statistics Canada is if you're in 8th grade, so if you're 13-ish years old, you should be able to understand, maybe not the underlying principle behind what we're showing you, but you should understand at least the words. You can read it. Yeah, so it's not much more I need to show with this one. And again, the word count, you want a very small word count. Again, I showed you the one with the hamburger, had a bit too many words. You want a small number. The fewer words, the better. And here's an example where they had this wonderful opportunity. This is self-admitted by them that they sort of messed this one up. They ended up plopping these graphics of numbers, these charts of numbers, on top of their cityscape and behind, where they probably could have done it slightly differently. When they did that roadmap one, they put the actual numbers in the signs and stuff. So there's some issues with the way that they produced this one, and they've sort of admitted that they've ruined the graphic, the skyline of the city of Montreal, by putting these charts right on top of it. So there's some issues there, but the more practice you do this, the better it gets. They like to use They can use this for sensitive topics as well. I'm not sure what the underlying theory of why using infographics for sensitive topics is, but they say it's more appropriate for sensitive topics. So I'll just take them at their word for that one. I'm not exactly sure why they think this is true or why this is true. So I'm just gonna let that one go. Okay, so here's one. It's sorry, I laugh at all these. Number of books read per month. And for some reason, they've mislabeled this thing with time and distance. And so they probably, hopefully, just got the title wrong and they're not reading a certain distance of books. So I'm not quite sure what they're trying to get at here. Yeah, I have no idea. But the title is obviously wrong. Why is it not good for labor force? I think the issue with a lot of the business type statistics is that the users of the business type statistics tend to be banks, or think tanks, or people that are like they're already engaged with your data 100%. It's You're not gonna the general public will occasionally look at your unemployment rates and they might take an interest to it, but that's not the intended, I don't think, the intended target for your labor force statistics. Labor force statistics are really intended more for policymakers, for the central bank, for things like that. So they don't need graphics. They just need, give me the data. What was the unemployment rate? And they want to be able to find the same thing every month. So I think that's that. Tracy, you have your hand raised.
Yeah, I just actually maybe did want to jump in for the Caribbean. I think that there is a little bit more of a promotional tool that the labor force type infographics provides, like in terms of their statistical advocacy with their general population.
Awesome.
So from that perspective, I think it's used a little bit more there to promote the excellent work that's being done within the organizations.
Yeah, that makes sense. So yeah, I said earlier that one of the things we're trying to do is we're trying to engage the public with our statistics. So if your office, if your country is trying to engage the population with labor force statistics, definitely use these things. Anything that's aimed at that's aimed at gaining more viewership, I want to say readership, I don't think that's right, viewership of official statistics, by all means throw this into some sort of chart, infographic. So I think an infographic is actually a very good way to do that. Thanks for pointing that out. I'm sort of stuck in the Canadian context when I think sometimes. Thank you very much for that question. This is a fun one. So as soon as we see this, we see right away that unemployment rates are dropping in Ohio. But then when we read the statistics, they actually go from 11 to 11.9, 11.7, 11.5. So it actually jumps and then starts going down. So this one, I always have to worry about why things are done. It could just be that this was a typo and they were supposed to be 11, 10.9, 10.7, 10.5. But there's always the concern of like, why is this mistake being made? Hopefully it's an honest mistake, but occasionally these mistakes come in and they're dishonest. And we're going to see an example of that coming up, which I find quite upsetting. This came from a bank in Canada. This is quite upsetting. I want the banks to be good with numbers. 1/3 of our operating budget goes towards financial aid. So as soon as we look at it, we see that it's 1/4. If the resolution's kind of bad here, but it says 20 million and 60 million. So 25% of their operating budget goes towards financial aid, but it's not 1/3, it's 1/4. And it's 3 times bigger, but that's not quite what they're saying. So again, they've made this mistake. This is a Canadian bank and it's sort of upsetting. Now, here's an incorrect use of a pie chart. So this was for an election. It wasn't a recent election. This one was years ago. The thing that I enjoy about this especially is they've added the margin of error down on the bottom as plus or minus 4%. So that's really good. So where are these supporters coming from? This person has 27% support from independents, 11% support from Republicans, 8% report from Democrats. What this should have been is it should have been either a bar chart to say these are the numbers, or if they were intending to show what percentage of support is coming from each group, they couldn't do it this way. They'd have to figure out what's the total number of people. Because, for example, I think, I'm not certain, but I think, well, I shouldn't even speculate. But let's say the number of independents is going to be different, I'll say it that way because that's got to be true, from the Democrats and Republicans. So you can't just glue these percentages together. So there's a lot of mistakes that are made with this. Again, if it was a bar chart, perfectly fine. But because it's a pie chart, they're sort of making you think about the entirety of this group, and it doesn't work this way. This to me is a beautiful example of scale being wrong. So ignoring the numbers. So this is a pitcher for the Toronto Blue Jays. He looks kind of sad. He's sad for a reason. If you look at this, the chart here, it looks like the speed of his knuckleball has dropped off by more than 50%. The second bar looks at least less than half the size of the other one. But if you look at this, it's a difference of 2 miles per hour out of 77. So what percentage is that? 2 point, I don't know, slightly under 3%, maybe 4%. It's a very small difference, but unfortunately, they made it look like he's lost half the power in his pitch over 1 year. So again, this is where using scale is critically important. They basically said, I guess the bottom of this might be 74 and the top of it's 77 or something like that. I'm not exactly sure. This is the one that upsets me. So this one is very upsetting. So this is the number of gun deaths in Florida. It's the number of murders used committing firearms. And we see at the bottom, it goes from the 1990s through to the early 2010s. We see this dramatic rise in the late 90s, and then this huge drop off after 2005 when Florida enacts its stand your ground law. So it looks like there's this huge drop. However, looking at the left axis, the y-axis, they've inverted it. They've flipped it over because they want, what they're attempting to show, the Florida Department of Law Enforcement, is they're attempting to show that this is a good law. But what happens is there's this huge spike in murders using firearms in Florida, but they like this law. So this is intentionally misleading. This one really, really upsets me. It's designed in a way to like exactly 100% flip on its head the result that it's supposed to be showing you. So at least they put the numbers in, so if you look at it, you can see it. But yeah, it's really problematic. This one's a fun one to me. This one, properly labeled axes, maybe axes. It's got the number of votes. It says it's non-scientific, so that's nice. So does the US President Barack Obama deserve to have won the 2009 Nobel Peace Prize? 50% no, 50% said yes. At least it's properly labeled. One bar is obviously, I don't know, 6 times bigger than the other, but at least because of the proper labeling, we know that the answer was 50% no, 50% yes. So again, a bit of bad math there. This one I included. This one is an infographic. This one I really enjoy. This one I saw just sort of cruising the net on personal time, but I like including this in this presentation because it shows how you can change the way that it shows the way that you can change the representation, the graphical way that people look at things to see what it's trying to give you. So have a look at this for a second, and I've blanked out in the bottom left corner what it is, but I'll see if anyone can come up with an answer. If anyone can figure out what this infographic is showing, throw it in a comment, and I'll see if you get it right or not. Okay, Tracy, so this question is slightly for you. So is it advisable for statistical offices to develop their own chart formatting guide, or could we borrow the Stats Canada one we presented in slide 19? So I assume the Stats Can would have no problem sharing their style guide with other countries, because I can't imagine why we wouldn't share a style guide.
Yeah,
Tracy,
definitely. StatCan can share the style guide, not a problem. And it's not an issue though if within your organization you have a certain style that you would like to adhere to. I think from our side the recommendation would be to have a set style that, you know, from one publication to another, that you're using like a standard formatting, just so that your users know where to look for their information, like that, you know, that this is the format of your titles, and it's going to be left justified or centered or whatever. So from that perspective, if you can have a certain set of rules that's used internally and that they're consistent, that I think that's the most important thing, along with everything else that Gavin mentioned about the labels of, like the axes and the legends and that sort of a thing. So hopefully that answers your question.
All right, so I've had a couple of people comment some answers here that it's about the continents, and we see from the bottom right hand corner that indeed it does talk about the continents as well. But there's something else going on here. Why are the countries labeled, like, obviously it's not geographical. There's something else going on here. So let's take a look. Let's take a look at the very bottom of the actual circle, not the little pieces that are going around the edge. So let's take a look at Colombia. So Colombia's got Panama, Venezuela, Brazil, Peru, and Ecuador. So what this is representing is it's representing who the land border neighbors are of all of these countries. So if we look at that bottom wedge at the very far left, you see Canada. The only land border we share is with the United States, and so that's why this is done this way. I think it's a really cool way of visualizing countries that border one another without having to look at the entire map. So sometimes it's obviously it's small scale. You can probably zoom in, but it's an interesting way to see how many countries border other countries. Anyways, I just really enjoyed that one, and that's why I like to share it. Okay. We've had a bunch of questions this time. That's very nice. Thank you very much for that. I'm going to stop sharing now. So I want to thank everyone for attending, well, at least today and potentially up to all 8 weeks of my presentations. I really appreciate that. I hope that you've gained some knowledge and insight into some of the statistical stuff that I've been teaching. As you noticed, it's not very statistical driven. It's much more survey driven. And it's much more about being introduced to these concepts and terms so that when you see them in your work, you're much more comfortable with them. Or if you think that you need to do them, if you think you need to do them in your work, then you get to see that, oh yeah, I should be thinking about this. I should research this a bit more.